Hey there, I got your message. So revolutions per minute. Yep, that's a little bit tricky. We are given in the givens in the intro to the problem that this is traveling at 0.75 radians per second. So we know it's angular speed. And now instead of radians per second, we're trying to get into revolutions per minute. So a radian, there's 2 pi radians in one revolution, right? And so that means if I divided 0.75 by 2 pi, that would give me what fraction of a revolution it's traveling in 1 second. So let me write that out right here. We know in one revolution there are 2 pi radians. And again, my answer RPM, it's helpful to think of what that really means. We want to get revolutions in the numerator, and we want to get minutes in the denominator. That's the units I'm shooting for, and these are the units I have. So if I divide out the radians, you'll see I'm now in revolutions per second. And this is called dimensional analysis, is the technique I'm using. You see it a lot in chemistry classes when you have to change units. It's really handy for that. So right now I have revolutions per second, and if you did this math I have right here, I think it comes out to about 0.119 or something. So it would be traveling, 0.12 revolutions each second. But I don't want revolutions per second, I want it in terms of minutes. So I need to get these seconds out of there. And I know there are 60 seconds in 1 minute. And so then if I cancel my units again, oops, I was going to change colors there. So radians canceled, and now I have seconds canceling. And if you look at what's left, I'm in revolutions per minute, which is where I need to get to, is RPM. And so then you would just multiply the 0.75 times the 60 and then divide that by 2 pi, and then you should get what they got over here, which is, this comes out to 7.16 RPM, or revolutions per minute. And again, all I'm doing here is using conversion factors. So I have my angular speed, it's just not in the right units for how they want the answer. And revolutions per minute is still, a version of angular speed. So by using 1 revolution equals 2 pi radian, and then 60 seconds equals 1 minute, those are true statements. And again, if I just follow those units, it lets you solve for this fairly easily. Yeah, so that's kind of what I have on that. There's other ways of looking at it for sure, but for me, I've always appreciated this version where you use dimensional analysis, because if your units don't come out right, you didn't do the right math. Again, you'll see this a lot in chemistry or physics classes as well. Hopefully that helps a little bit. Holler if you solve a question.